Hello, everybody. Yeah, so back after Thanksgiving break, which usually comes at a nice time. Always comes drawing near the end of the semester when everybody's starting to get exhausted and overwhelmed. So a couple days to relax. Need too much food is nice. It looks like we have 2 weeks left. I guess our last class day will be the 13th. The semester ends on the 14th. So I'll go ahead and start putting out reminders now. I'm usually kind of lenient with legwork and stuff. I understand things happen in life, but remember there is that definitive end to the semester, 11:59 p.m. on December 14th, which is a Tuesday. All the assignments will close and shut down. And then first thing Wednesday morning when I wake up, I will submit grades. And I am an early riser, so it'll probably be done well before 7 o'clock that Wednesday morning. So, yeah, make sure everything's turned in before then. But we've got a couple other things to go over between now and then. First thing, starting tonight, we're going to look at graphical user interfaces. Doing all our software to run in a console just seems a little out of date, right? I remember when back when computers did do everything in the console, and then when Windows came out and we were able to click on things, or I guess Xerox actually invented it, but Mac kind of did theirs first and had the mouse and could click on things instead of having to type all the words, avoid the typos that way, all the symbols. Then Windows came out, spread the popularity of it even more. I thought we were done with consoles, but that's still the way programming is introduced. Personally, I would have started this class with graphical user interfaces, that modern appearance where we click on buttons and things, but I wanted to be consistent with all the other heavy text. So we're going to spend a couple nights going over that. I have a list of things here from the project proposals everybody turned in. I kind of put together a list of things I want to make sure and cover. Some of them, because they might be a little bit tricky, so I thought maybe working a small example into class. A small version into the class example may be helpful for your project, and then other things just because it might be useful, and I think we'll have enough time to cover them. So that'll hopefully be helpful on your project. And along with that, what I had in mind for tonight, starting out, is those reference examples that I sent out last week that kind of showed the basics of what a graphical user interface should look like at that top level menu. The old style, but that's just layout options. Which, by the way, TK interface does take CSS for anybody that's had Cascading style sheets somewhere. That's how we style it. But we won't really have time to get too deep into the colors and stuff. We're just going to worry about the functionality of it here. I know that's very common. So some of you all may have seen CSS before, but that's how you make the TK interface package take CSS. But that's just styling options. We have that top level menu, then a toolbar underneath that with buttons and icons on them. And then the main content, and down at the bottom, the status bar, spitting out strings to show the current state of what's going on. I sent out that basic reference, and then I decided that as we go over it, why don't we turn that into a starting template that we can use for the projects, and kind of have a big thing going instead of just a bunch of small scattered pieces. We'll kind of work on that, go through the stuff that way. We also want to look at Github. That's part of one of the requirements for the final project is to put it on a repository. And GitHub's one of the most popular ones, been around for a while. We'll talk about repositories when we get to that. Basically, it's a place where we can share our code, or we don't have to share it. We can keep it private there, and it's an online storage place for code. Kind of like libraries, the way we import libraries from the stuff we installed with the Python language, we can import straight from a repository. We don't have to necessarily download the code and put it on our computer to use it. The repositories are set up for that. So we'll see some of that. And yeah, then we can constantly update it. So we'll see the first bit of GitHub tonight. And then Wednesday, when we get back to add even more stuff to our graphical user interface, we'll download the versions we put on GitHub tonight and just update them and go over branches and how we update the code we keep on there. Then, so a good place to cover about a couple things. But first off, just some quick concepts to go over. New term here, we can call this event-driven programming. So you all probably remember in your SDEV 120 class, words like menu-driven programming. I think that's one that consistently shows up. With console-based stuff where we would spit out in the prompt, we would give a bunch of options. Right? Like
that's basically our final.
Yeah, y'all remember, right? What was on the final?
Do it. Build an ATM.
Okay, yes, the ATM one, yeah. So the menu would be like, what do you want to do? Enter the username and password, and once you did that, do you want to withdraw or deposit or transfer or exit? And we'd list out the options and the user would have to type that in directly. Well, in a lot of ways, GUIs are an expansion on that. It's just the options are already put under buttons and pictures. Oh, speaking of which, I almost forgot to do it. I sent it out right before class. I sent out some files that we'll need for the example tonight. You might want to download those while I'm talking here at the beginning. I almost forgot to do it. So yeah, 5:47, 13 minutes before class, I sent out some examples. Or files that I'll be using in the example this evening, but really it's like the pictures I'm going to put on the buttons. So loading in a picture is loading in a picture. We just tell it which picture to look at. So if you want to follow along in the example, it'll be there. And I meant to send, I had those ready to send out last week, but I didn't want to send them out until we got close to class time, and then forgot till like right before class. Like, oh yeah, I better send out those files. Oh, if anybody wants to follow along, we can have the same pictures I'm loading in. So everything we've done so far pretty much just ran in order. We had branching and stuff, but for the example, I'm going to simplify that in our flow chart. Pretty much, we had the start. It went down. Do some stuff. There might be some branching things there, different loops. Some loops might come back around a few times. With the menu-driven programming especially, we keep coming back around in our main loop and then eventually end the program. So our flowcharts essentially look like this, start to the end every time. We might have loops or some recursion or invoke some pre-built functions that we could jump out of our sequence, run that other function and come back. But basically we just ran from the start bubble to the end bubble of the flowchart every single time. There wasn't as much variety. But y'all are probably well aware that modern software, we start it up and then there's not necessarily a definitive beginning or end. There's running or not running, and then everything that can be done in that software, we usually have access to the whole time. Sort of a different process. And we handle it by event-driven programming. Much like the menu-driven programming, only instead of listening for a particular menu option, we're going to listen for an event. We start the software, and then it sits there and waits for something to happen. And that's what an event is. It's just something that can happen. Maybe a button click, pressing keys on the keyboard, certain keyboard combinations, mouse click, touching the touch screen or swiping on the touch screen. Or to go further, timers, alarm could go off and say it's time for this thing to run, or different sensors. And in the thermostat, the sensor could detect that it's 75 degrees and it's supposed to be 72, so it's time to turn on the air conditioning unit. Or vice versa, the sensor could detect it's down to 60 and it's supposed to be 72, so it's time to turn on the heating coil. Sensors and things. So basically just things that can happen. That's an event. And with event-driven programming, there's something I want to point out right from the beginning. It's really easy to find. I'll go ahead and do it with this sharing the screen. So if we just search for event-driven programming, you'll probably already know the top result is going to be Wikipedia, right? Which sometimes isn't the best source, but a lot of times it's still valid information. It's a lot better to use the sources listed on Wikipedia than to use Wikipedia. But there's usually bibliographies and good information. And searching for event-driven programming is no different. Wikipedia is right at the top here. Kind of the summary of it, talking about the different things, talk about some of this. There's this section, criticism. I wanted to note this right from the beginning. This stuff is important, so you want to kind of keep it in mind as you start to work with event-driven programming. Because these things are going to work in quite often. So the criticism on it is it leads programmers to create error-prone, so there's a lot more room for bugs to happen. Right? When we can do the same thing by either left-clicking in the right spot, or maybe Control-Alt-M to run some function, or right-click and choose from a menu. Lots of ways to make the same thing happen, which means there's more ways for bugs to work in there. So there's error-prone, difficult to extend. It's once we put them together, it's kind of hard to make them bigger, right? Because we have to approach with a plan of how all this stuff can interact together. And if we come up with something new that we want to work into that jumble of interaction, it might be hard to work that new feature in there. Difficult, not impossible. It's still very much possible, but sometimes it takes a few more steps than we would expect. And excessively complex code. So the coding starts to look like a mess. I'm going to go over the naming convention I like to use. I'll go ahead and preview it now. So to try to keep things straight, there's going to be at least two levels, right? We're going to have, in the background, we'll have the variables holding the data. And then in the foreground, we're going to need a place, a reference to something to display, a text field or a label or something on the interface to display that data, and a different thing in the background to hold that data. So there's different ways to keep it straight. What I like is a naming convention that in the background, we use camel case for the variables. Remember, that's the one where all the words get jammed together, so no spaces. And each subsequent word starts with a capital letter, but the first letter is lowercase. And put the variables there to some meaningful name. And then the thing on the interface, what the user can actually see, has basically the same name, only in Hungarian notation instead of camel case. Which, because of the textbook grading, I had to drop that. That's something I've always made a big deal out of in this class before, is all the different naming conventions. But the auto grading thing would sometimes look at the variable names you all are using. So I couldn't really make a big deal out of it before. But Hungarian notation uses a short prefix, like 2 to 4 letters to indicate what it is. So if we had, say, output, that's something that's going to be in everything. The final result in the background, the variable, we'll just call that output, which is only one word long, so it's all lowercase letters. And then the thing on the interface that's actually going to show that, like if it's a text field, would be txt output with that little prefix to indicate it's a text field. And then the same word is that same useful name as the variable holding it. That's the convention I like to go with, so we'll see that this evening. And then use Pascal case for the methods. And that way the names can be very related. So the methods that involve output, like set output or get output, we can just add a second word on there for whether we're changing it or retrieving it. And write those in Pascal case, which is just like camel case, only the first letter starts with an uppercase letter. The first word starts with an uppercase letter as well. So kind of mixing and matching the naming conventions so that the same useful word applies. That's a very common way to handle that. And the one I like to use also happens to be one of the most popular ones. So we'll see that here shortly. But remember those things. They're a little more complicated. They're a little more complicated to tie all these levels together, the background and the foreground, and make everything work, and work in multiple manners, right? So we can right click on something or left click on a different button or hit some keyboard shortcut to run it. So different things to do it, leave us more spots where bugs can work in. So error prone, difficult to extend, and excessively complex. Just keep those things in mind as we kind of get started looking into this. Conceptually though, it's fairly straightforward. It's just, I guess this quick summary of that right there is don't let it get away from you. Keep your plan in mind. Right? Even if you're doing like fully agile sort of development where you know it's going to change and stuff, you're still going to have some sort of plan when you go in there. Agile development isn't approaching it without a plan. Agile development is approaching it with the plan that your plan is going to change. Your plan is the adaptation. There's still something in mind that you want to do. So just kind of keep things like that in mind. And I feel it's fairly intuitive. Hopefully you all won't have too much trouble, but as always, I'm always happy to help. If you have trouble, just let me know. So event-driven programming. So changing from this to almost more of a circular flowchart. We have that start the software and shut down the software. And then our flowchart just kind of runs the whole time. It's constantly coming back to that position it was, the waiting position. Maybe instead of start and end, I'll say start. And then we have that wait for some event. Wait for event. And when that event happens, we do the appropriate stuff. Wait for the next event to happen. Could be a button click, keyboard press, some sort of timer or alarm. Let's see, my notes here talk about object-oriented programming, which we haven't seen yet. And in Python with the TK interface, we don't have to do it in object-oriented programming. A lot of books like to jump ahead into that, and it kind of makes it seem confusing. And really the advantages that we would get from doing everything on a graphical user interface, object-oriented style, aren't going to show up at an intro level course. It's the advantages don't show up till they get much more complicated. So we get into observables and things like that, which kind of show up at the end of the 200 level course for the first time. Yeah, events are basically just anything that can happen. And then we have two parts that we work with for an event. We have event listeners and event handlers. And the names kind of imply what they do. The event listener just sits there and waits, pays attention, waits for an event to happen. Waits for a certain event to happen. So we have to set up all of our listeners. Anytime we want to listen for a button click, a mouse click, or a keyboard press, or a timer. We have to set up a listener to just sit there and wait for that event to happen. And then the handler basically runs code when I'll put notified by listener. The event has happened. English is nice. We have the multiple articles, unlike some languages, so we can specify the difference between the or a. But the event that we were listening for has happened. That one and only one thing has happened. So it runs the appropriate code. So run appropriate code. Or since a lot of people are visual learners, tie that into that flowchart picture I drew right here. The wait part is our event listener, and this whole do stuff circle is the event handler. So the listener just sits there and waits for whatever event it's programmed to listen for. And when it hears it, it's a good term to use there, then it notifies the handler that, oh, it's time to run that the appropriate code. So two parts to put them together. And some technical terms, we have to put the listener somewhere. So we will bind the listener to one of our components. Bind listener to one of our components, which with the TK package, we refer to those as widgets. Just some technical terms that might show up on a quiz for you. And I think that's pretty much what I had. Bind quantitative GUI. When the listener detects the event it's listening for, the ascribed handler will call the appropriate code. That sounds more formal than what I just wrote on the board. Sounded a little nicer that way. Maybe I should look at my notes before I wrote it on the board. But anyway, that was pretty much what I had in the notes here. This is an active subject we learn by doing, right? So let's look at an example. So I sent out those files right before class, which that's just the images. You might also need the files that were sent out last. Oh, that's actually the list here. I share my screen here because on this computer, it's already opened up. So right before class, I sent out those. That's just some pictures. And then last week, when we first talked about GUIs, oh yeah, the announcement listed reference material we might get to tonight. We saw it last week, but we'll use those files. I figured there probably wasn't much need to send out the same thing twice. That might start to clutter stuff up, get confused on which one's which. In particular, there were two versions of that, and that reference material did the same thing. One of them was fully object-oriented with the class notation, and the other one was just modular, just everything written in one script with regular functions. Technically, they are still methods in Python, but one of them class notation, one of them just regular Python syntax. And since we haven't covered class notation in our classroom lectures, we'll just use the modular one for tonight's example. So I'll go ahead and share my screen. Yeah, so the files for class were just some pictures. Those were actually from another piece of software I was working on recently. Project management software is always for big scales, like days, weeks, months. But I really like to use project management software when I plan my lectures. Instead of like a monetary thing on the resources, for those who have seen project management software, I'll kind of do a rough translation thing where I cover difficulty level and describe that like a monetary value. try to keep things balanced. That way it's not too much difficulty stuff all back to back at once. If we go over a difficult topic, follow it with an easy one and kind of plan out the time. And I like to use project management software for that. But it's always for big things. So I had to make my own that would handle minutes. Actually, it goes down to seconds pretty well. It can schedule things from seconds to years with no problem. It's not the traditional business-based project stuff. But that's what those images were from. And I thought they would work to put on buttons, basically. It's like, okay, here's some quick images we can put on buttons and tell which one's which. You all have seen my classroom example, right? That people data, name, age, town, maybe favorite food. I think we'll have favorite food on there tonight too. But just some simple little data about people for the simplified classroom examples. So those buttons seem like they would go well with that. Along with that, I'm going to grab the stuff from last week. We will start looking at this. This is a teacher put this together about 10 years ago, maybe a little more now. But it very, very quickly became the premier reference for TK Enter, or Knitter. You'll hear it pronounced different ways. It does stand for TK Interface Package, which started on one of the precursors to Linux, Windows X. It was before Microsoft Windows, but the word Windows showed up as a precursor to Linux. I want to say Windows X is where that started. And it was written in a language called TCL, which in Python is fully integrated, has been from the beginning, because when he started working on Python, he was doing stuff in the TCL language. So it's part of the origins of it. But in other languages, we might have to integrate the TCL language ourselves, which sounds fancy. We just have to import the library that recognizes the syntax from the TCL language. Once we import that library, we can go ahead and type it in whatever language we're working in. But in here, there were two different files. One of them was the class notation, object-oriented, and the other one was just the modular. Technicality aside, I'll call it modular Python scripting. There's the technicality that they are both object-oriented, but the modular style, where we just put our variables in there, and we don't have to refer to the script we're writing explicitly, write the functions without having, where we have to worry about the order the functions show up in. That's one way to say it. We don't have to compile it before it will run, because it is still an interpreted language. So something always seems a little odd about having to compile an interpreted language before it'll run. But we'll grab that modular one and just hit copy that, and come back over to that folder with the stuff those pictures I sent out. So we'll need those. And then we'll start modifying this, which I think I will do in Spider this evening. Been using text editors the whole time. I think from the screenshots y'all have been submitting when you do turning your homework every week, I think most people have been using Spider, right? It's a really nice IDE. It has some nice features on it. And it was fully encoded. It was fully written in Python. I'm not sure which interface package they used. It might have been TK. I think they use WX Python. That's the package I would generally prefer to work with. It has some nice features. WX Python, like, I'm pretty sure that's what they use for Spider. Because if we want something like a Python programming text editor, we don't have to import put in a text field on our GUI and then do all kinds of crazy adjustments. There is already a Python text editor widget that we just go ahead and install. And then we do extra customizations on it. Oh, and yeah, it looks like the one from when I was getting ready is still here. So before I close that, let me show you what I had in mind. We also have an example we did last week. It was just a hello world. And we got there either from a top level menu or a button in the toolbar or right click or keyboard press. So we're just gonna take that as the starting point and expand it a little. We'll add a couple more menus in, which aren't really, just to put, I only had 3 buttons in mind for the first night here. So just to put something in each one, I just put one of the functions in each one. They should probably all go into the file or the edit or something. Put up there buttons to either add data, to remove a piece of data, or to edit a piece of data, which the add data is the only one we're going to get to tonight. And then stuff for the data, so like a name, an age, a town, and a favorite food to choose from a list. I think everybody has seen, I'm pretty sure everybody's seen my generic classroom data that I use. And then we'll add that to a list. And then Wednesday, when we follow up, we'll do the edit and delete buttons. But with the list, we can, it's a list, so we can select things off of it. Let me point up real quick. From Sellersburg, Lake Tacos. So there's more than one data set up on the list. We can choose between them. And then Wednesday we'll come in and do stuff when we select from them. But that's kind of what I had in mind, to be a starting point. Right? That way there's some buttons in there. So for your final project, all you'll really need to do is just change what function the buttons call. Hopefully make that a little, make the final project not so overwhelming. You can focus more on the Python and just picked up bits of the GUI. So I'm gonna go ahead and close this and then open that file that I just copied over. What is this one? Actually, before I copy that, I'm going to rename it. It's going to be kind of a starter template, so I'm just going to call it that. TK enter starter template. So that's often a good idea. Reusable code. And that's one of the things we're going to look at when we talk about GitHub here in a while. Give that a name and then I'll open that. Personally, I kind of like the nights that are all examples and not tons and tons of stuff written on the board, because it's a very active subject, right? We learn a lot more by doing it. So I'll open this up. And I think there's a picture missing. Let me change the, I didn't copy over both pictures, so. Here we go. What pictures do I have? Add person. I'll stick that there. Well, actually, I'll just comment that line out. What's that? That'll work. I'll just change what image that is so it doesn't throw an error when I run it. And look at our starting point. There you go. So the picture is much bigger, but we have this little hello world thing. We looked at that last week. And we kind of talked about that when we looked at methods, reusability. There's no need to start from scratch every time. If we don't start from scratch, we can get a lot further. That's why I wanted to do this. And that's part of the concept behind what the public repositories where we store code is, which is something we're going to look at tonight. So I guess first off, that original one was for example, so I'm going to get rid of a whole bunch of these comments. Remember that criticism we looked at just a moment ago with overly complex. So one thing I like to do is organize the code. I'll make these big comment lines to kind of separate things, put a bunch of white space in between them. The white space with no indenting or anything, so it doesn't cause any problems in Python. And have these big long labels that help to find stuff. I'll get rid of a lot of these other comments, which we'll see here in a couple weeks. Instead of comments like this that just say something and sit there, we'll look at some comments that will generate a website. That way you can put your document, when you put your comments in there, it will generate the entire website documentation. Much more useful than just arbitrary words that only the person looking at the code will ever see. I'll leave that comment because that one is this. If you want to put a context menu, always looks exactly like this. That's copy and paste code. Once you have your menu set up, you copy and paste that line of code to turn it into a context menu. Actually, we won't need the say hi method. I'm gonna get rid of that. But before I hit delete here, note that there's two of them. This is something that comes from the TK interface package being one of the earliest. There was something that they thought would work out well, but didn't work out as well as they thought, but it still persists. And textbooks mention it and things, so we'll look at that. Something other, before event-driven programming was really refined. And it results in that we need two methods. Even though one of those just calls the other method, they have a different number of arguments. And one of them doesn't take in any parameters, and the other one takes in a parameter called event depth. So when we put our templates together, we'll just kind of work around that and just do one method, and then change that old stuff that didn't persist into later languages. Some comments, we get down to the GUI section. So that's the line that starts it. The TK library dot TK object. We ask for one of those, and then that gets us a little gray box with the minimize, maximize, and close button. The little slash, hide, that's what it is. The hide button, the minimize, maximize button, and the close button. Along with the default label and stuff. So I'm going to change the title. Might as well change that here. This is going to be our Gui Starter Template. I'm just going to leave that icon on there. You can leave that off. There is a default TK interface icon, which looks like a feather. I want to comment that out so we can see what that icon looks like, the default one. And then the geometry, we'll figure out a good size once we have some stuff on there. More comments that were for that original reference one. But you'll have access to that original reference one, so you can use it there. Here's where that error showed up from deleting the methods. So we're calling that. And this is the old thing. Instead of binding to an event, one of the is there at the very beginning. I could probably zoom in more. I didn't even think about that. I think, does Spider have zoom? Yep. Control plus, the normal control plus works. But I guess you all are logged into the thing now, so you got to see it locally. Can everybody see that okay on the screen? Should I zoom in more?
Looks good.
Yeah, that's big enough.
Okay, so this is the old thing. So instead of events, because that was still a new concept when they developed this package back in 87 to 89. They tried to do it as parameters. It's just a parameter for that thing, and it didn't quite work out as well as they thought it would. So that's one about the TK interface package that still persists. And a lot of books, especially introduction level books, like to reference that because it can be easier to work with. But I was going to kind of work around it because it's the regular event binding is what took off, and that's what will work in all of our other interface packages. There's other ones we can use in Python. WX Python is my favorite to use. We might take a look at that at the end if there's time, at least a very short version of that. That's the one that for styling it and making it look nice. TK, we can use cascading style sheets for those who've had CSS, the HTML 5.1 standard. TK does take that. So we style it with regular cascading style sheets, just add in some identities and types and things like that, and it should look very familiar. But the WX Python, instead of we usually don't apply any style to it because that's the package that will ask the operating system what a window looks like or what the widgets look like. So if you put it together and run it on a Windows 10 system, it asks your operating system, okay, what's a button look like? And then it looks like a Windows 10 button. You take that same code over to a Mac and run it, it's going to ask the Mac OS, what's a button look like? And then the buttons will look appropriate for running on a Mac system. So that is a big advantage over that one, that one has. So we'll probably try to take a quick look at that. It is a little more complicated to use than the TK package. So starting getting all these comments out of the way, they don't generate any code. We can run code in our comments. So arbitrary comments like this just seem excessive to me. Let's see. I'll keep some of those short labels and get rid of the explanation comments. And then we'll start updating stuff. Might as well keep that one because we might need that for reference. That's another reason to think about this is y'all have probably gone and looked at reference material by this point, right? Not know how to do something, so go look it up. And sometimes you have to look a couple places because you'll find an example and they'll like show screenshots of it running and stuff and be like, that's strange. And you'll look for the same things a couple Google results down and it'll make perfect sense. Because we have so much wiggle room in how we write our code. So the second one you looked at, might have been somebody that writes their code a lot more like you do. So it just made more sense when you looked at it. And to take that even further, is to refer to your own stuff. Right? 9 months from now, you're probably not going to remember every single thing that you did in Python. Right? It's always going to be there, the general idea, but some of the little particulars aren't going to be fresh on your mind if you don't see them for 9 months. If you don't see them for 3 years. So one thing, another very useful thing about repositories like Github that we'll see in a little while, is just to build up your own reference material. As you put stuff together, keep trivial, simplified examples there that you can look up whenever you need to refer syntax you haven't seen in a couple of years, or at least long enough to have forgotten what it is. And here's the other critical line at the very bottom, the GUI, the thing that we said was a tk.tk object. Way up at the top, those two critical lines. The top and the bottom are TK library. And we created this reference GUI, which refers to the TK library.tk object. Sounds a little redundant when I just read it like that, but hopefully the typing there makes sense. And then when we get way down at the bottom, which will probably be better to put like this, because we've seen this. If name is equal to main, then we're going to run that main loop. You usually want to do that in pretty much every Python script, right? make sure the right thing is loaded up. Which basically means if we hit the play button on this script, didn't load this in. And just the reference we came up with, .main loop to make that happen. And all this stuff in between is the custom features that we want to address. So first off, we'll start setting some things up, maybe some methods so that we can call and get something to run. Well, I'll come up here and set up a place to store stuff first. Okay. My classroom standard example in classrooms is just some data about people, name, age, town, good generic data to work with, easy to make things up quickly. So I know I'm going to have a collection of data, so I'll just go ahead and set up a list for that. There's another list we'll come back and get to in a moment. And a couple things. Well, we can see it here on Spider on the screen. Down at the bottom, there's a status bar. Like our status bar for our example is going to be a little bit simpler. It's just going to have a string spit out, say what's going on. But that might be a good method to start with. So we'll start with that. Define a method called display status that takes in some sort of string. I'll just call it status. Oops, wrong language. Sorry, I was doing C# earlier this afternoon. Tried to put the curly braces in there. Need a colon in Python. But this method, define a method called display status. It's going to take in a string and basically just spit it back out to our status bar, which I'm going to do some renaming here. So I'm going to go down to where the status bar is created. Call it current status. And remember earlier, I said that's going to follow a naming convention here. So the variable in the background where we keep track of our status says ready to do stuff, or adding data. Data just successfully added. Data field successfully deleted, and things like that. It tells us what's going on. That'll be the variable called status. And then on the foreground is something with the same name, only in Hungarian notation. So a prefix that says what it is, which our status bar is going to be simple. It's just a label sitting inside a frame. A frame is just a container. So we put a label in there. So the Hungarian notation is a little prefix to indicate what it is. It's a label, so I'll put LBL and then status. And that way the background and foreground thing are actually have the same name. One of them is status, written in camel case, and one of them is LBL status to indicate that it's on Hungarian notation to indicate it's on the foreground. Does that make sense? You look confused, Emma. You had a confused look for a second.
Oh, no, sorry, I'm just trying to see it.
Oh, do I need to zoom in more?
You're fine, I can kind of see it.
Probably had a little more room. I'm not really looking at the stuff over here. Actually, I can probably.
That's fine right there.
Okay. So kind of just a way to name that. Only what I just did isn't the best way to update code. And so I'm going to hit Control Z and undo that and do that a better way. So I'm going to select that word. And this one has different keyboard shortcuts. In most text editors, it's Control H. But some things have switched it to Control R, as in replace. So the find and replace is if we just change it, we have to dig through our code and find every single place that shows up. Sure, might be a lot of them, right? So it's much better to hit the find and replace, which is either Control H or Control R. Control H is indexed to go to, because I guess when they put it together, the thing that made the most sense. Control G for go, and then the following command is the next key over for replace after we go to it. But either Control H or Control R is in replace. And here in Spider, it's Control R, the replace one that kind of makes sense. And since that word was highlighted, that already put in the find section. So find current status, and every place that shows up, replace it with LBL status. I can't really zoom in on that, so hopefully what I said makes sense. That Hungarian notation I just used zoomed in where we could see it on the screens. Can't really zoom in on this part, but find everything that had that original name and replace it with the other one. And then once the zoom buttons go away, there's a button to replace all of them. And just replace all of them at once, and it probably says somewhere how many it replaced. I think it's behind the buttons on mine. I'm guessing in the status bar. Oh, but then it say, but they did change the color to indicate there's no more of that original one. That original name doesn't show up anywhere in there. So whenever you go to rename things, you want to make sure and use that find and replace box. So I'm just going to go ahead and keep it open because we're probably going to do that again. So now that we have a good name on that, let's load it in. We'll talk about things. Then we will change it. So up here is the method. Oops. And the convention I'm going to go for with the methods is Pascal case, which Pascal case is all the words jammed together, and all of them, every new word starts with a capital letter. Camel case is almost the same, except the first letter is lowercase. Usually I make a big deal out of that in this class, but because of the auto grading with the textbook, I couldn't do it like I'd done it before. Especially positional notation, it really does like that. But yeah, so we're gonna pass a name like that, and then we can refer to that thing on there. And notice with the Hungarian notation, we can get to the predictive text very, very quickly because everything's going to have that short prefix. So once we type in that prefix, we can find everything with like all our labels. So we have the label status, and then all of our parameters. Let me scroll down and point to this. Everything for the TK thing, all of our parameters, the label, the command, or it's probably not many others. Here on the label, the text parameter is the one we're interested in at this point. All of those parameters are stored as a dictionary. We saw dictionaries a couple weeks ago, right? It's an indexed list, but our indexes are strings. So if we want to get to that label, we'll ask for the widget, which we call LBL status, and then all of the parameters around it are a dictionary, so we can just put that parameter in as the index for that list. So the text parameter of the status label will just get changed to say something like status. I'll make that all caps. Status plus that string we passed in. And just for good measure, I'm going to go ahead and cast it to a string. Because if it's already a string we want to put there, that won't hurt. But if we pass in a number, well, you all know what happens if we try to print a number. Python doesn't like that. I'm sure everybody's seen that a time or two now. And we're going to have a lot of methods. So I didn't mention this one last week. Closing curly and curly brace languages, like the C family, our closing curly brace can end up a long ways from the start. So it's very, very useful to put labels on those. And in Python, we can do the same thing. When we get to the end of the method, just put a little comment here that says where it's done, where we're done with it at. To help us prevent confusion with what needs to be indented and whatnot. When we have curly braces, the closing curly brace could be 50 lines away from the opening one and have 10 more sets of curly braces in between. So it's easy to get lost in those. So putting a comment by the closing curly braces can be really useful. And if anybody's transferring to IUS after this, when I went to IUS, 3/4 of the computer science teachers required every closing curly brace to have a label on it. So it's a good habit to get into, even if we're in a different language. It's still useful to know, make a note of where that indenting should stop. That's the sort of thing I use regular comments for. A lot of times, the only regular comments in my code will be these sections, like great big long string or whatever the comment symbol is, and usually, let me zoom out to kind of see it. It goes further. I'll add some more in this one to express the point. That line goes way further than any of the lines underneath it. So that if I need to scroll quickly to another section, I can look over there past all the instructions and find those section comments trailing off. Just a useful little thing I've found over the years to help organize things. And that's pretty much all I use the regular comments for. We'll see before long our comments that will generate websites and then we build all our documentation for the comments. It's much better to read it on a web page than in the text file. That's kind of hard on the eyes. We can make it look really, really nice on a web page. But that's the basic idea of what we're going to do with this thing here tonight. We're just going to update it to a good starting template and follow these conventions. So these are some naming conventions I would really, really like to see on your final project. The variables get camel case, the methods get Pascal case, and the things that actually show on the screen get Hungarian notation. And that way, you don't have to come up with different useful names for it. All of those were called status. And we just use the different way of notating the word status, either camel case, Pascal case, or Hungarian notation to indicate which one we wanted. Then we didn't need to come up with multiple useful words for what's essentially the same thing. And to help address that issue, that's a common way of addressing the issue of that we looked at on the Wikipedia page, that overly complex error-prone stuff when we get too many words in. This one, from the earlier example, was not in Pascal case, it's in camel case. So to fit the convention, I'm just going to copy that down to the find and replace box and change that first S to an uppercase S. Wait for the zoom buttons to go out of the way. And once the zoom buttons are out of the way, then click the Alt. That way, any place that method's called is now written with that in that convention, which is one of the that is a very, very standard convention. There's lots of programmers in the world, right? And we're all unique individuals. So we would do things different. And so these conventions help us to do things. I don't know when it's going to run again, but that was one of the big ideas with the Java programming language that really made that take off when it did. Because Java is essentially C++. It's C++ that runs on a specific machine. There are lots of things we can do. Really, what they restricted was they took away the lack of warning messages. We can't break our machine without at least ignoring a warning message is the biggest difference between C++ and Java. But C++, thousands, millions of programmers around the world have just kind of done their own thing for a decade. And it had turned into an unwieldy monster. It was a mess. There was no keeping track of it. So what they did, well, there was a big project, so they sat down and started trying to clean it up some and get a version of C++ libraries together that they could work with that were nice and clean and organized. And that eventually grew into Java. So there's a lot of freedom like most programming languages, but when we write things in Java, it's very strict, or it's not strict because it won't throw an error, but we stick with those same naming conventions so that all of us write our code the same way. Not quite a grammatical rule and things that like it won't make the computer crash, but other programmers would kind of look at you if you didn't follow those naming conventions. They would look at you and be like, I thought you said you knew how to program Java. Because that's mostly what it is. It's just those almost grammatical rules so that we all write our code the same way and the language doesn't turn into an unwieldy monster that nobody can make any sense of anymore. Because that happens when millions of programmers who are all unique individuals all do their own thing. You can think of it like elementary school English languages, English classes, right? We have those list of rules, but if we don't exactly follow them, people will still know what we're saying. We can spell words wrong and people still figure it out. Make typos in the sentence, and we see a sentence with typos, we can still figure out what it means. But those grammatical rules make it kind of clean it up, make it easier to work with and to do, especially between different people. So that's what the conventions like that are. I'm not going to make it a hard requirement, but I would like to see it here. Please keep it in mind. And those continuing on, you will see it as a hard requirement more later on. So I'll just mention it here and maybe keep it in mind as something worth practicing. Is the microphone still working?
Yeah, it hasn't gone out at all.
Okay.
Loud and clear.
This is usually where it cuts out. So yeah, as normal, if it cuts out, send those symbols, but IT's been working on it. This is actually a new one. They replaced it. So hopefully, maybe it was a hardware problem. Okay, so now as we go through here, we need to make some adjustments on these red lines so that we can run a test. And then we'll take a break and do the rest of the adjustments with those naming conventions and things. So we set up our main window, then like the title and the geometry, that's just the size of it. That's a standard cross-platform way of specifying sizes. We can pull that from the operating system and then size our window based off the screen we're looking at. It's a much better way, but I want to try not to overcomplicate it too much here for our example. But that's a standard cross-platform method of sizing things. It's just pass those numbers in as a string. But I think, well, I saw homework from everybody in the class here. You all know how to pull those numbers out of a string if you need them, right? You have a string with two numbers and an X in between them. So you shouldn't have any trouble grabbing those numbers if you need one of them. Let's see, there's an error here on the file menu. So to set up that top level menu, we need a couple objects. We create this main menu, which again, isn't fitting that naming convention. So I'm going to go ahead and change that. I guess if that's closed, all you have to do is put your cursor by the window and then hit Control R. I guess Spider doesn't do that. Usually that will bring up what we're looking for. And to fit that convention, the Hungarian notation, it's a menu. So I'm going to give it the prefix MN and then main. So instead of spelling out main menu, I'm just going to switch that over to Hungarian notation and use the find and replace to switch them all at once so I don't have to go look for that. So switch all those. So I went through and updated every place that needed done. Then our I thought the other one was already here. Might have had it. That must have been what beeped a moment ago. So that gets our menu, and then whenever we set up a new object with the TK interface package, our library there, we'll refer to that the library. Then the dot is kind of like it has. Whoops, didn't mean to move that. So that TK library has an object called menu. And then we'll start passing in parameters. And the first parameter is where we put stuff. So this main menu, the only parameter there is the GUI. So that means we're going to put our main menu right directly on the GUI. It's going to be the top level menu. We have to do an extra step to configure the main menu and the context menus, which is not hard. It's just one word. Somewhere down here where we load stuff in. So for the main menu, that top level menu, or if you style it to look like a hamburger button so that it hides and shows and probably goes down to the side instead of across the top. A new, more modern look, which is just position on the screen, nothing fancy there. The place where it's going, which in this case is the main menu or main window, then .config, and then menu equals whatever we want our main menu to be. So you have to do that for that top level main menu, however you lay it out, but that's just one word, which is now in this file. So if you'll have this, that you can keep as reference material forever. So if you want to add a comment in about that line is necessary for our top level menu. And well, at this point, we only had the one menu in there, the file menu. So first, it's a menu. Then where does it go? This one goes into our main menu, which we already changed the name of, changed them all at once with that Control-R thing. Tear off equals 0. That means we can't move it. It stays put. It stays put. That's another feature that didn't really hang out after the early ideas that showed. That's another one of the early ideas in the Git interface package that didn't stick around. We used to be able to take our main menu from the top and reposition it around. The user could do that, but it didn't stick around. So for the top level menu, you probably want to set the tear off equals 0. That way we can't move it. Sorry, that way the user can't move it. Only we can move it when we put our code together. Then we're going to add a button to it. Well, I know what buttons are coming, so I'm going to go ahead and say add person. Just for our generic example here, I'm going to change the text on that. The label, the command, we're adding commands. You can see what it reference to that menu, which should probably be renamed again to follow that convention, which again is just a good idea. It makes it so you're consistent about writing your own code, which makes it easier to keep track of yourself. But it also is very, very helpful for other programmers to reference your thing. And that one I'm using here is a common convention, so we might as well go with that. So I'll copy that word down to find and replace box. And instead of calling that file menu, I'll use the prefix mn to indicate the menu, and then file. So the menu called file. Oh, and replace all of those. Which, yeah, I thought about leaving the names the same, but then I realized that changing the names helps to see what's referenced and what's built in. Because notice the reference name changed, but that on the next line, that thing we're doing to it, dot add command, that didn't. We're adding something to the file menu, right? So like here on Spider, up here we have the file menu, and when we click on it, it's full of commands that are related to files. So we just use this method to add some, add command, give it a label, and then what are we calling? Which we don't want it to run immediately. I'm gonna go ahead and mark out the thing, but not actually write the method yet. So basically just leave a spot for the method. Define a function called add person. And this function is going to be called from button clicks. Right? That's our main feature. We're going to add data to whatever application is going on here. It's a trivial example, so all it's doing is holding the data. By next Monday, it'll be filtering the data. That's one of the things that ranked up near the top on my list is add filters to some data. Right now, it's just going to hold some data, but it's going to happen for button clicks or keyboard shortcuts, different events. And when we bind things to events, when we set up our event listeners and handlers, that event comes with it. We get information like if it's from a mouse click, we get the coordinates of that mouse click. We get two sets of coordinates. We get where it was on the GUI, where it was on the screen coordinates, and the local GUI coordinates. We'll get more things. If it's a key press, we get other information, like how long it was held for, if it has been released yet or not. So other information comes in with our, when we listen for an event, there's a lot of other things involved with that event. So all that information has to be passed into the methods that the handler needs. So really with the TK package, that's our handler part, is we just make the first parameter. If we need multiple parameters, make sure the event will always be the first one passed in. That's our handler. So to handle the event, we just pass in the event itself as the parameter. And I guess in this case, I'll just change the status bar to say coming soon. So I'll call the display status function and pass in the string adding data coming soon. Just a placeholder. And then I'm going to put a closing label here to keep track of what should be indented and when we're finished indenting and all of that. And add person. So most of that should look familiar from our pass on functions and methods. I guess the biggest difference is that parameter, the event that happened that is called for this method to be called is passed in first. And then just to deal with that issue, those issues we looked at on that Wikipedia page, common issues that we want to keep in mind when we do the event-driven or graphical user interface-based programming. Things to clean it up, help keep it organized. We want to keep that in mind right from the beginning, so we don't have to come back and try to clean it up later. Or minimize cleaning it up. That's called refactoring. There's a button that'll do it. That's why I was doing this in Spider, so we can click the refactor button in a little while and have that cleanup stuff for us. Now, when we call this from the method, calling that lambda command, there's extra parentheses there. We don't need quite that many. Lambda is going to work. That means wait. Our textbook went on for a little while about it. Essentially, it goes back all the way back to the 50s. And it's saying, okay, as the CPU is going through here, processing these instructions, it's going to see this instruction that calls a method, which now needs to be add data. It's going to see the instruction to call that, go ahead and call that add data function. But we don't want to call it when the CPU sees it. We want to, so lambda is just saying wait until our event parameter is filled. Wait for an event to happen. And then when that happens, we'll pass in the event. That's what it's usually going to be. However, in this case, these old ones where it's the command parameter, not binding to an event, it's a parameter. It predates event handlers and listeners, would have become the standard. So we can't wait for the event. We just say wait, and it'll kind of work out. There's some complicated stuff going on the inside to make it work. We'll say put in the lambda to say wait, but when we call this method, it's expecting an event to be passed in. And from the command parameter, which we have to use in those menus, the menu, because, well, you can see from the name there at the beginning of the line, it says add command. We didn't add a button. It's not a menu button. It is a menu command. So the command parameter isn't going to have an event like a button click would. But the method's expecting one, so we can just pass none. Why is that still giving an error? Oh, because I called it add person. There we go. And if you call something from that command parameter, which is only available on the menu items and the buttons, we can bind anything to events, but that command parameter, if you use that, you either have to pass in none to fill that event parameter, or you have to write two methods. And it's probably a better idea to write one method and just pass in the null for the parameter. Especially if you might come back and update it. Same thing here. I'll copy that down here, do it much quicker this time. Paste that in here and rename it with the conventions. It's a menu, so it's a context menu. That is the technical term for the right-click menus. Most of us just call that a right-click menu. And if you think it would be helpful for your own future reference to call it a right-click, feel free to do that. The technical term for it is context menu. But most people get all the way to programming classes and have never heard that in their entire lives. I've never heard anybody call it a context menu. It's a right-click menu. So that might be a little more useful name, but I'll just hit that to change them all at once. This function right here, you'll notice the only thing that changed, it changed the name of the menu we want to show. The menu we want to show .tk_popup. And if you're in 8.0 or later, you have to do the grab release so that you can move it. Earlier than that, it would only happen where you right click that. But if you want to move it out of your way, you'll need the grab release as well, which I think has to be there. And then event, this is that thing I was saying, the mouse click. That's coming from a right mouse click. So there's an X position, whoops. There's an X position and a Y position. And I have no idea what the 0 is. I dug and dug and dug and looked at all sorts of different tutorials and reference material, and examples always showed that 0 in there. It doesn't work without the 0 there. But I couldn't find the documentation that actually says what that 0 is for. I tried passing in different numbers and didn't notice any change, but I dug around and couldn't figure out what that 0 was for.
Even with a 1?
Yeah, I wasn't noticing any changes. So it's not true or false. Pass in floating point numbers, integers, all sorts of things. But it was written back in between 1987 and 89, and probably didn't get documented very well. If it got documented well back then, it was on paper, right? So that was before HTML. That was before the HTTP protocol. So it wasn't documented on a website, and it apparently never got translated over. But if anybody ever finds out what that 0 is for, please let me know. I dug and dug and dug, and just, it doesn't work without a 0 there. It doesn't work without a number there. Most examples just have a 0. I have no idea what it stands for. But that is copy and paste code. All you have to change is what's on your thing. People have been copying and pasting that since the 80s. So that's probably why I had such trouble finding this, because nobody even remembers what it's called for. Then we'll need the same thing here. It's a command. It's a menu, so we added a command, not a button. I'm gonna take off the extra parentheses. So when we call our add person, so the first item in our context menu is going to say add person. We call the add person method. And along with that naming convention, notice I'm trying to be careful with the labels, the variables, the methods, everything, all the names line up. Because it can get a little confusing afterwards. How many other error messages are there? 3 more error messages, but it's probably time to take a break, right? We've been at this for a minute. So we need to do that same thing 3 more times, so maybe after a 10-minute break would be a good spot to review that again. And change the button click, the toolbar button, the main content button, and the keyboard shortcut. So at least 3 more times, I think. But we've been at this for a minute, so it's probably a good time to take a break. Does 10 minutes sound good to everybody? Okay, so 7:21, we'll get back to it at 7:31.